This is AP Computer Science. My name is John Maxwell. So today we're going to look at the for each loop. In fact, we may actually look at the negatives about the for each loop, but it certainly has some promise. And let me give you an example. In this problem, we're looking at an array of nums called nums, right? 13.5, 6.7, 23.15, 8.2, and 17.9. You can read them as well. And I'm interested in coming up with an average. And in order to average, I have to total all the values. So let's look at the for each loop here. What this does is go from the beginning of nums element at index 0 to the last element, taking each element and storing it in n. So it extracts each element one at a time, stores it in the placeholder variable, in this case double n, and from there I add n to the total. So with the total I can calculate the average at a later point in the program, and if you're scanning the screen you can see where I do that. You know, another typical algorithm is finding the maximum value in an array. And you know, once again, I think you've seen this in the previous video. There can be no value that's lower than the min value of a double. And so I set max to the lowest possible value for a double. With that said, almost any value of these will be higher than the min value. And the reason why I used min value again is if I set it to 0, it would be a problem, because if the array had all negative numbers, 0 would be the maximum value. So, I don't want that to happen. I just make sure min value, right? Max is min value. Running through the array of nums and storing that in n, okay, one at a time, straight through all the way to the end. And then asking the question in the if statement, if n is greater than max, then max equal n. So in order to output the average, I divide the total by the length, and that would be fine because they're both doubles. So I'm going to get an exact number. One of the things I learned from you about is the decimal format class. So I created a decimal format object called D and set the pattern to be X pound sign hashtag dot 00, which says if there's spots in the first three positions where the hashtags are, go ahead and do that. But after the decimal point, make sure that like every number is accounted. And so let me run it. Okay. So the average is 11.21. Let me kind of show you what it would be without the D format, the decimal format. Okay, so I may have duplicate braces, but it just show you what the decimal format does. When I ran that, I didn't like that number, 11.20999999. So what I did is put the decimal format in, and that rounds to including the hundredth, displaying a value regardless of whether it is 0 or not. So 11.21 is more satisfying. And this is the way for each loops work. Start at the beginning, dump it into the placeholder value, continue all the way to the end. And from the point of view of common algorithms, totaling, averaging, finding min, finding max, other algorithms like that, which will find their way on the AP exam, the for each loop in conjunction with a list or an array and or string, or later on we'll cover array list. These are pretty useful. But they do have some problems, okay? And let me show you some of the pitfalls. So I created the same array, by the way. We had discussion in class last night. This creates an array of 10 values, space for 10 values, all with the value 0 at the start. So, I want to test if they're in increasing order, right? In other words, this number is bigger than that number, and that number is bigger than this number. So if it's in increasing order. So what I'm going to do is comment out some of the other things that I'm doing here, and run it or show you what the increasing order is. And there we go, increasing order. Well, I couldn't do this with the for each loop, because if you look at line 16, I'm saying if I is greater than I plus 1, the value at index I plus 1, then it's not in order, and I'm going to return false as soon as I find that it's a mistake. Okay, I'll print out the array is not in sequence and return false. Otherwise, I'll return true. Okay, and here's a statement here. One thing that I noticed is this I plus 1 always leads to an out of range error. What I want to say is less than the last index, so that when I get to the second to last index, I plus 1 would indicate the last index. So I need to adjust the stopping condition so I stay away from the very end index, so I don't go I plus 1 index out of bounds. That index out of bounds, when you're doing comparisons like that, is something that they'll try to trick you on in the test all the time. Every time, tricking you. So let's run this and see what it looks like. Hopefully all the changes haven't made. The array is not in sequence because, hey, it isn't in sequence. But the point is that the loop pitfall, you couldn't do this with the for each loop, because a for each loop takes one value at a time out of the array, and that's all. You can't access the element after it using square brace notation I plus 1. So this comes into play in a lot of ways. Let's look at remove index, where I want to remove index 2. I hate 23.15, so I want to remove index 2. So let's look at that. I send in the index and the array, and I start at the index plus 1. Why? Because I want to take that number and shift it down to the value that's already stored in the index. The index, I minus 1, is equal to index at I, which is the one past the one we want to replace. In other words, we're overwriting it. And that's kind of cool. So let me actually go ahead and run this. I'll show you the problem. Now, you may think, wow, an array, right? I want to remove an index. Yeah, people lose customers all the time. Products get removed from the lineup. People quit the team. You want to remove an element in the middle of an array and shift the element after it down to cover up the missing space. Let's run it. Okay, problem. It removed the index 23.15 at index 2. Good job, but it left 17.7. That's because the element at the last index had no shifting. See? There was no shifting down. What is? That's the end of the array, so there can't be a shift. Well, There is a library in the arrays which makes a copy of nums and reduces the size by 1. So takes a copy of, and I'll store it back in nums and watch what happens now. Okay, actually out of order. So what I want to do is go ahead and cut this and put it right after I remove the index, Control V. Basically what that's doing is removing the last index, 17.9. And indeed it did. Okay. Remember, I told you at the beginning of using an array is one drawback is they're limited in size and not easily resizable. Well, that seemed easy enough using the library and the arrays um, class, copy of, to copy to a new size. And it is, but like it actually isn't, because if the array was pretty large, you'd be doing a lot of copying of values from one array to another. So that's n on the order of n it would take to do, as n is the size of the array. Never mind. Okay, so adding an index. Okay. You know what? I want to add to nums at index 2, 32.1. I'm just going to copy that out. So I'll add to index 2 the value 32.1. And so it should fit right after negative 6.7, if I got it right. Again, and add an index, and this is in chapter 7 of our textbook. Okay, you can see code similar to this. One, I want to first off increase the size of the array because I'm adding an element. Okay, this was declared with an initializer list. So it started out as 5, I reduced it to 4 elements, and now I need to increase it back up to 5. So I increase it using the copy of in the array sub library. Then what I start is at the end and work my way back forward. So I is at the end, it equals the one before it. In other words, I'm shifting out from the end. Shifting out. The one at I is equal to the one before it. Okay? And then after I shift it all out, I plop the value in position I. All right? And return nums, which is specified in the return type. Let's run that. And 32.15 is there. Okay. Does add and remove an index appear on the test? Not really. Not very often. But like, how often do people have to add and remove in the middle of a list or an array? Pretty common as a data processing type of operation. So, do I teach you Java or do I teach you AP Computer Science? The idea of adding to an array and removing from an array are definitely useful concepts, and they cannot be done with for each loops, because you can only access one value in the list at a time, or an array at the time, and you can't access adjacent elements using square brace notation. And that's the walk away from loop pitfalls. The for loop is good, yes, for certain operations, common operations, algorithms, as we will cover in IMAC. One last thing. Here's the array size issue. And I have mottos, which is 10, and I'm going to print out mottos. And when I print them out, I get no, 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 no. Because when you create an array of ints or doubles, the values are 0 or 0.0. Point 0. When you create an array of object types, they're all null until you create a new object and store it in these indices, as I do here. But I do only have a partially filled array, logic size plus plus. It starts off at 0, there's no elements. Each time I add one, the logical size of the array gets bigger. The physical size is always 10. I can only fit 10 values in indices 0 through 9 in the mottos array. But each time I add the mottos, I increase the logical size. I can print it, all right? But when I print it, I still get all the null, null, nulls right here using the arrays.toString method in the arrays class. But if I use logical size in the for loop, less than not len of mottos.length, but just logical size, I just get simply the mottos that have been initialized and put into the array. So occasionally this differentiation between logical size and physical size is a concept that's testable on the exam. Not the prime thing. You more like be able to add and total and average and find max or find elements in a lit array that match a certain criteria, and you can use a for each loop. Those are perfect for it. But like for situations like the loops that I described last with adding and removing or comparing two elements to see if they're increasing or maintaining the number of values in an array, the for each loop will not work. So is this about the for each loop or is it about bashing the for each loop? I'll let you decide.